to be like interactive, less of me teaching and more of just like facilitating the discussion. And you know, there's a place to share our expertise and what we know. So feel free to chime in at any point. And this should only take, you know, probably 15, 20 minutes or so, and then we can kind of open the floor and talk about like visualization with mapping with geospatial data and those kind of topics. But yeah, so I sent around last week 2 articles. One was a Medium article, very common like blog with lots of data science-y, Python-y posts. So there's like a starter tutorial on GeoPandas. And then the other article, just to recap, was a little page about adding base maps to like your visualizations using the contextually package. So maybe we'll get into that a little bit get into that one as well. But to start, I will share my screen because I basically put all the code from that tutorial into a notebook. So I can share and show that, and we can kind of walk through it together. Okay. Can y'all see my screen?
I'm good.
Sweet. Yeah, so adapted by the tutorial by Hannes.
Increase the maybe zoom a little bit on the text?
Oh, yeah, definitely. Let me see if I can.
Thanks. That's better.
I can hide this. Oh, I think it's something like that. Or it's minimize it like this. Cool. So there's a lot of imports. I made an environment. So I'm actually working on the VAC user node because just for my own work, that's what I've gotten used to. But I can definitely export this Conda environment I created to our virtual machine if people want to run this notebook themselves and get that installed so we can have all these packages. But anyway, so I made a GeoEnv environment that contains all the packages we need. GeoPandas, contextually, shapely.geometry is sort of the base class for GeoPandas objects. So basically, if you have like an area, a geographic like area that you want to cover, that's like an object in GeoPandas treats that as an object. So there's polygons, there's multi-polygons, there's lines, there's points. These are all object classes from shapely.geometry from that package. So that's kind of like under the hood what GeoPandas is using. Let me open the tutorial too, so we can kind of reference that. Another page. So, in the tutorial, they used public data from Seattle, so I just went with that as well. They used like some publicly available data that had kind of a map of neighborhoods, different districts in Seattle, and they also used a map that had public schools, like where are the public schools in Seattle. So those are the 2 data sets. If you follow the link in the tutorial or in the notebook, basically Seattle Geodata Neighborhood Map Atlas, you can download. You have lots of different formats. You can use shapefile or GeoJSON for GeoPandas, at least from what I've used. I'm not sure. This might be a topic of discussion if anyone knows if there's like what the major difference between these 2 are. I know GeoJSON is much more readable to the human eye, but I'm not sure if one might be more compact than the other in terms of storage size or space. But in any case, GeoPandas can read shapefile or GeoJSON, and maybe these others too. But for the tutorial, that's what we worked with. So here, read in the neighborhood data. Got to do my imports first, which might take a minute. There we go. So GeoPandas is very similar to Pandas in the sense that like the root class is like a geo data frame. And it's just like a regular data frame, as you can see here. But the unique thing about a geo data frame is what's called like the active column. And that is the column that is sort of, you specify, GeoPandas are usually smart and can tell which column is active, but it's basically, you want that to be the column that contains your shape objects. And here that column is geometry. You can see for each neighborhood, there's some other columns, other information, but these shapes, polygon, multi-polygon, that's the geometry. Kind of confusing because it's named geometry, the column name is, but that's also like an inherent attribute of a GeoPandas data frame. Whenever you call, for example, the data frame, whoops, let me get typing here. You can call it like an attribute instead of, and that'll return the active column. You can also, but I just want to clarify, in this particular data frame, it's also a column name, right? So we can do this, it returns the same thing. But we could rename our column in the data frame anything we want. We can name it neighborhoods, we can name it shapes, we could name it, whatever we want, but it's still going to be returned by this neighborhood.geometry attribute. So a little confusing, but just wanted to make that clarification. And you can set, if GeoPandas doesn't read in, automatically know what column is your geometry or your active column, then you can use this method set geometry, and then you would pass your column name in there, and then now say whatever the name of this column, if it was a different name, you could change it to that, and then that would set. That would let GeoPandas know what column contains your shape information. So as you can see, the type of these objects are, at least the 10th one is a polygon, but again, from that shapely class. And if we go through sort of the list of columns in the data frame, we see most of them are just regular old Pandas series, and then just that one geometry is a geo series. So that's really the big difference between a Pandas data frame and a GeoPandas data frame. GeoPandas data frame has one column that's like your has your geometry class, basically. You can have multiple geometry or like geo series in a geo data frame, but only one's going to be active at a time. And what that means is when you call different geometric operations or methods, they're only going to be applied to that active column if you have multiple geometry columns. It's from the docs. Probably encapsulates what the point I tried to make earlier. So again, this is all in the docs to read as well. And then there's coordinate reference system, which is kind of what it sounds like, the reference system for the coordinates. You can check that by checking the geometry column and the CRS attribute, and it'll tell you the name of the coordinate reference system. It looks appropriate for us, right? We know our data is from Seattle, and it's northern Seattle, and presumably in the county that we want. So that's a good way to kind of check your reference system. You can change it with this toCRS method, and you can specify an EPSG designation. EPSG, has anyone heard of that before? I'm just curious. Okay, I see Pat shaking his head.
Yeah, it's a long list of standard CRSs that are defined for you already.
Yes, thank you. And so I have some links here to kind of more information on CRSs. EPSG is like this nice database. Apparently it stands for European Petroleum Survey Group. So it's kind of a antiquated name because they do much more than that. But you can find all sorts of different data sets and CRSs from there. So just put those links in the tutorial. And then I'm not going to actually change it because the CRS is actually fine, but you could change in place to true if you want to actually modify this neighborhood data frame. All right, so now let's explore some main attributes of the GeoSeries. So our particular data frame already has an area column that was in the data that we downloaded and opened, which is convenient. But you can also calculate the area of the active geometry GeoSeries column with this area attribute. So if we did neighbordf.area, it'll calculate the area, and we can see the one we read in exactly is the same as the one that's calculated. So that passes the gut check. Boundary will return just the boundaries, shapes, like just the boundaries of your shapes. So remember, if you have a polygon, or maybe if you have a square or whatever, it just returns the edges of that square or of that shape as a series. So this will correspond with our GeoSeries, and you can see it's all lines and multi-line strings as opposed to those polygons because it's just the border. You can also calculate the centroid. Here we're making a column, but you would use the neighbordf the dot centroid attribute, calculate a centroid. So that's the center of each polygon. And that can be useful, for example, for calculating the distance between 2 points. So I'm going to ignore those. So to get the downtown centroid, for example, using some regular pandas methods to get where the neighborhood named downtown, we want the centroid of that. So then we have the downtown centroid. And now let's calculate a column that's a distance between the center of each neighborhood. So for that distance between the centroid column to our downtown centroid. And now you see we have distance to downtown. And in our row for downtown, naturally the distance is 0. And the rest of these are distances to downtown. And the units for all these calculations are going to be the standard units in your CRS, which is handy to know. And so I think the CRS for this one was in feet. So that's what the units we see here are. But just something to keep in mind if you're wondering about where units come from. And there's a lot more geometric manipulations on the GeoPandas docs, so I encourage you to check that out. But just to keep moving forward, let's read in the public school data. Oh, I just had this to show that the shapefile, reading in the shapefile and reading in the GeoJSON effectively returns the same geo data frame. So if anybody knows the difference between the two or has any arguments for like why you would want one or the other, I'd be curious to hear about that in a few minutes, or now if you have any reason or any thoughts to bring up on that. But if not, feel free to interrupt me if you do. But going ahead, let's the tutorial did a simple operation. Like, so this is, again, taken straight out of the tutorial, filtering schools that are located in Ballard, which I guess is a neighborhood in Seattle. So we're using this within method. And this I found a little interesting. There is a within and contains method in geo data frames, or in GeoPandas. And they're kind of the inverse of each other. So they're sort of interchangeable, but they're the inverse in the sense of the expression A contains B is the same as B dot within A. So here we're just taking within to get all of the Ballard schools, or all the schools that are within that Ballard neighborhood. And from here, we had a little bit of code using the within method just to figure out how many schools there are in each neighborhood. Now we get a list of how many public schools there are in each neighborhood. Yep. Okay. And now finally getting on to mapping. So GeoPandas has some built-in plots using so just like some base plotting, kind of how Matplotlib has base plotting. And that'll look like a pretty rudimentary map, as you can see here. Just kind of the axes being feet, presumably. It looks like, yeah, it looks like feet. Just the units of those coordinate systems of that, yeah, coordinate reference system. We can add the schools to the map as these points. So those are all the public schools. And you can also make an interactive map using this explore method, which uses a Folium map. Folium is a different package that GeoPandas is accessing under the hood to create an interactive map. And so with this little bit of code, you can actually create like a pretty cool interactive map you can zoom in on. There's pop-up labels, your scale there. And you can change the tiles, for example, which is basically that base map used in the background. So if we wanted to use satellite, for example, we could do that, and you get some satellite background instead. And that about wraps it up. That's how you kind of can do some exploratory data analysis with GeoPandas, how do you make some quick maps out of that. Again, I don't have much experience with mapping, so this is just what I whipped up from that tutorial in the past week. So I'd be curious to hear if anyone has any suggestions or feedback. And other than that, like, yeah, let's just open the floor. People, I guess to start, who has experience with like mapping, GeoPandas or any other package, like making kind of like interactive map, or not even interactive, any kind of maps? Nobody?
I
Cool.
don't have much experience, but I did use the explore maps here. We were doing some sort of like creating documentation for a Python package I was working on, and that worked. It worked really. Yeah, I like the explore maps there. I feel like pretty easy to customize in some basic ways. So I like those. I think I also looked at trying to use like the Plotly package, and there are a few like, I don't know, things that were just kind of bugs that prevented using Plotly more, but that worked pretty well too. But the GeoPandas Explorer was easy. Actually, I could maybe put a link to that, and it's some examples of using the Explore maps for mapping stream gauges. Let me see if I can find that. I think we have it public now. So.
Yeah, I've used Plotly before in R, but also in Python they have a.
Hey, Noah, your audio just cut out. Noah, can you hear us? I think his audio just completely went. Thanks, Sharda. You're a quicker typer than me. There you go.
Oh, we had you for one. We had you for one syllable.
Oh, okay.
You're back.
Okay. Looks like I'm back.
The
I was
last
just
30
mentioning-
seconds or so, you were out.
Okay. Yeah, I was just mentioning Plotly. Yeah, that's a great echoing what. Yeah, Plotly is a great package. I think it was first implemented in R, but they also have a Python wrapper for it. And you can also, obviously, the other point I was making, you can also make any kind of chart. You can make like histograms, bar charts interactively, time series, like just like line graphs, in addition to map. So you can make like a whole kind of suite of different graphs interactive with Plotly. And I believe you can save them also as, yeah, with Plotly, I know you can save the interactive plot as an HTML, which is really cool because then you can put it on your website or a web dashboard, or just save it, send it, pass it around really easily as an HTML file, and then anyone can open it in their browser, and interact with your graph, your data. So Plotly is a good one, and yeah, I'd be curious to check out this Folium package more because I haven't really spent that much time with it. But it seems to do a lot of the things that Plotly does. So be interesting to check out those two.
Just have a question on the install. I've just been poking around the edges of it. It says that installs can be tricky because it's got a lot of C-based dependencies for GeoPandas. Did you have any issues getting it up and running?
I made a new environment for it. Yeah. So I made a fresh Conda environment, and then basically one by one, I first installed GeoPandas because that also installs, this holy trinity and Shapely and a lot of other things. And then I think the other ones I had to manually install were Contextually and PyProj.
Did you just do a Conda install?
Yeah, from Conda Forge channel. But yes.
Yeah, okay. Yep.
Conda install. And I can set up this environment in the VM too if people have it. I just am so used to working on the VAC now that it's just where I SSH into with my VS Code. So I didn't log out and log into VM when I made this yesterday. But
do you think we want to make a standard or a GeoPandas environment that we all share, or do you want us to all go and kind of bake around for now?
Not unless there's a strong need for one that we all use. But I think, yeah, I mean, if a lot of people are using it, and a lot of people are in trouble with it, then I'll put one together. But I think the use of this is pretty sporadic at this point, so make your own. But I'm
that's fine.
Here to help you.
I just wanted to know what direction to go. I know I didn't have it available right now in my notebooks. I needed to go build it.
Yeah, other than that, I'd be curious to hear what you guys have to say in terms of what kind of data you all have in terms of what kind of mapping, if you're working with geospatial data, what kind of data are you working with?
I'll just provide a historical context. The only time I've tinkered with this, we had generated rasters of land use data that was evolving over time. And I used or toyed with it using Google Earth back when you installed it locally and worked with it on your desktop to apply the raster over the top of whatever the local map was and registering it with the map, which was kind of cool because then you could do basically fly around it. I mean, it was Google Earth, so you could. What I had done was created basically a flight sim that you flew down the watershed, and it showed you the colorized land use in a sort of a transparent overlay on the ground data, which was cool, but very hard to manage. It wasn't programmatic at all. It was a lot of manual tweaking in Google Earth. So not the direction we want to go right now, I don't think.
Okay. Yeah, roster.
Oh, sorry.
Oh, no, go ahead.
Oh, I was just wondering if GeoPandas can do things that like QGIS can. Because right now, if you like working graphically with your data, I feel like QGIS is a good route to go. But is there any functionality that you're missing by doing that versus like GeoPandas?
That's an excellent question, and I wish I knew more about GIS because I don't. I have zero experience working with GIS or ArcGIS. Or what was it you said? QGIS?
Yeah, QGIS, which I think is
Basically,
has a lot of
it's
Python on it under the hood.
Yeah, so I have limited experience with QGIS, but I'll weigh in on this. And so QGIS is pretty heavyweight. Like it has a ton of stuff in it because Python underlies all of QGIS. So when you're using QGIS, you're really using Python. And so yes, you can do a ton of stuff with like that framework. I think they're pretty compatible, to be honest. I think QGIS comes from the context of GIS users. So everything is like very shapefile, very ArcGIS kind of centric, right? That's where they kind of got their inspiration from. The GeoPandas comes from like the pandas side of things, right? Like data frames, adding geometry, putting together quick maps. I would say that the amount of code to do stuff in GeoPandas tends to be a little less, but it's also like you do a ton more in each step because it's kind of like it makes a lot of assumptions for you to make it easy for a programmer. I don't think there's a right answer to your question. I think it's kind of which context you're coming from is what seems easier to you. If you're used to ArcGIS and the GIS software, QGIS is going to seem really obvious to you because all those functions that you write out in Python are just basically clicks in the interface. But if you're kind of more of a Python person and you're used to data frames, GeoPandas is going to be right up your alley because it's a pandas data frame with additional column that tells you how to plot things. So it really, I think, is based on the user and what context you're coming from is what's going to be easier. But in terms of functionality, I don't know. I mean, the graphics come out different. Like one uses Folium and one uses whatever QGIS has in the background. And I do think that the GeoPandas stuff is moving much, much faster. Like as new graphing packages come out, whatever's going to replace Folium. Folium is like has been out for like a year and a half, 2 years in like really active use. That's in Python terms, that means its time span is about up. There's going to be something new that comes out that everyone's going to think is better and use that instead. And I'm sure GeoPandas is going to support it in like a very short period of time. QGIS, you're on like a 20-year development cycle. It's been around forever. Everything is super stable. Your code's going to work in 5 years more than likely. And with GeoPandas, that's much less likely because it just moves so fast. So some pros and cons.
Yeah, thanks. I had heard of GeoPandas before, but never. I think I tried to use it like way back when I was first like learning how to write code, and I had a lot of trouble with the install and everything, and I think I bailed because of that.
Yeah.
Yeah.
It's interesting.
And that's another fair con. Like, QGIS, you install it. I mean, QGIS install is not fun, but at least it's kind of all self-contained. GeoPandas, you got to pull couple different packages down, make sure all the versions work. It's a little bit more of a art than QGIS.
And with QGIS or Esri, you can do some stuff that you cannot do with GeoPandas, especially when you're like want to manipulate your save files, vertices and stuff like that. It's more difficult to do programmatically than to do it on an environment like QGIS or ArcGIS. So there are like some stuff that it's easier to be done in QGIS or ArcGIS, and other stuff there's no need to use these kind of packages. And GeoPandas or in other languages like geodatabases are maybe faster or don't have to deal with the user interface.
Well, in defense of GeoPandas, sometimes you need all your data in one place, and it's just sometimes it's frustrating to do all your geospatial analysis in GIS or QGIS and then come back to Python to do all the rest. And yeah, in terms of doing geospatial analysis, definitely QGIS is very helpful and most of the times better even. But when you are working on something and you want to do something related to geospatial things and something else maybe is related to time series analysis, that you don't want to go back and forth between these two. So it's definitely would be easier. I just want to mention that the link Scott shared, and it's very interesting, Scott. And some of the plots are for Vermont, so that's really interesting to look at. And I know you made those plots. The visualization is really great, and the functions that you wrote, I think those are really great sources for someone who is just starting to do geospatial data analysis, because there's not that many good Python codes, at least, to kind of start. And these are really helpful.
Great, thanks. Yeah, yeah, it's Vermont because I was helping write the documentation. I'm like, I'll use Vermont as an example.
Yeah, I will second that, Scott. Those are really slick, and the code is very concise, very small. It's not doing a lot of extra stuff. It's very cool. Yeah.
I find it exciting looking at all these libraries because I've not worked with geospatial data a whole lot. And when I did, way back when, like at least 2 years ago for a class project, I was taking a data visualization class, but it ended up being a visiting professor and he ended up making us use JavaScript, CSS, and HTML instead of Python. So I made all of these interactive plots the hard way where we're adjusting pixels and stuff. But I'm pretty sure Plotly and Bokeh both use JavaScript under the hood anyways. So definitely nice to see how it's more streamlined, that process. Because I remember making like a website and making interactive plots on them, and it took me a lot longer than some of the codes that I saw in these example links that Noah sent, as well as obviously what Scott just sent.
Yeah, it seems to me that like
if anyone
GeoPandas.
wants, yeah, to play around with that code more, you can get the. Oh, go ahead.
Oh, sorry, no, go ahead, Scott. I wasn't sure.
I was just gonna say, if anyone wants to play around with that more, that link I sent, the notebooks you can download directly, like from that that code repository too, and just run those. For GeoPandas, I think if you want to use those like interactive maps, you need to also install Folium. I'm not sure it installs. If you just install GeoPandas itself, I think there's a couple extra packages there to install to make those. But then you can just load GeoPandas in one line of code there with the Explorer map that works well.
Well, no, thanks. I thought this is a really good article you found. I'm blown away by how simple it is to do some of these like calculations like within and distance and stuff. And so I think those are some really good examples of like the power of this GeoPandas stuff. You know, if you instead of again, you know, I think if you have like one task to do, using an interface like ArcGIS and QGIS is great. But if you had to do that distance measure like 25 to 100 times, clicking around interface becomes a big pain in the butt. And so this really, you know, allows you to kind of automate some of those things, I think, really nicely. And those, yeah, those example calculations I thought were super cool to see that work so easily. If you asked a question about GeoJSON and shape, and I'll throw my 2 cents in. I always have an opinion. You guys know that, whether it's right or wrong. So shape is great. It's been around for freaking ever, right? It's like the GIS OG of data formats, and ArcGIS uses it, QGIS uses it. GeoJSON is like the next generation. It's kind of the open source like communities version. All the new Python stuff understands GeoJSON. It's used a lot in like web APIs. They return the GeoJSON version of, you know, the geometry. So I would say that like as a community, the programmer community is definitely moving towards GeoJSON. You're starting to see more and more of that. But I mean, the ArcGIS folks have been using GIS for years. Will never give up their shape files. So that's good. And there's a couple lines of code you can use that Adil passed around to me that can convert between the two. So it's pretty much a mute point at this stage. I would guess GeoJSON is probably a little bit longer, probably a little more descriptive without digging into it too much, just because JSON isn't designed to be compact. It's designed to be readable.
Yeah, you can looking at the GeoJSON files for some of that Seattle data. Yeah, it's just like hundreds of lines of latitude and longitudes to like to 10 decimal places. So like it may be readable in terms that it's characters that we can read, but it's not very helpful. So it may not be.
One
Again,
thing
like,
that's
read either one. So
one thing with the JSON formats is it's often easier to do some programmatic parsing or modifying, editing of those. If you want to go sweep through and change stuff, it's a lot easier to find, you know, navigate through JSON or JSON in general to know that you're in an object and you find the attribute of the object and you step on it and then you move on. It's harder to do that in a shapefile.
I also think shapefiles have a maximum file size. I think you can't go past 2 gigabytes. GeoJSON definitely might allow bigger file sizes, but it's also harder import and transfer. Also, I think there are attribute limitations for shapefiles. You can only have a certain number of attributes and character names for each attribute. So depending on how big the data is, I suppose, and how much you want to download would determine the kind of choice that you want to go with.
I don't work with a lot of geospatial data, but I've also seen like geo packages used, or I think you can bundle multiple, like, you know, equivalent of like multiple shape files like together. And GeoPandas, I think, can just open those geo packages directly, I believe.
You know, I have a question about the tiles. So we didn't go much into this, and then you know that second article you passed on with contextually. So in that last function you showed us with the Explorer, there was a tiles parameter. Could you put a contextually tile set in there, or do you have to, or does it have to be a string?
I think when you're using the explore method, it's a string because this is sort of like it's like you have less like kind of control over this explore function. But there was some other code in that tutorial that I was messing with to do that, where they actually use contextually.
Okay.
Yeah, so that's CX, add base map. So this would be using contextually to add a base map to your axis, which is like, you know, basically your figure. And so this must be the default base map. But if we go to that second tutorial, we can see, so again, maybe you plot your data, just the regular GeoPandas .plot method. You can create your axis object, and then when you add a base map, there we go.
Could you zoom in a tinge, Noah?
What's that?
The text. Can you zoom in a tinge? The text is pretty small. There you go.
So this looks like the default base map for contextually, but you're adding a base map to your axis. And then you can change base map. sort of like these keys, there's different options. So I actually, looking at this now, it looks like that explore function is like the strings are these keys in the background, right? OpenStreetMap. There might be some other ones that Explorer has access to, but these are all different sort of base maps that you can use that contextually provides. Or I guess those are providers, and then you can have names of tile sets.
Yeah, for a provider. Cool.
Yeah, and then here I guess you can pass the source argument. You can specify providers, especially provider, and for the provider, what kind of tile set you want. This happens to be positron. But for the explore function, I think I'm just messing around with some of the different keys that are available. Open world imagery. Then the other one I used was OpenStreetMap. You might be able to use. Let's see if we can use like. Oh, whoops! Back to different key. Wikimedia. Let's see if that works. I'm just curious now if we can use a different one. Well, maybe not.
You missed the A on the end of media.
Oh, did
You
I?
swiped
Thanks,
the whole
Scott.
string.
That might be why it didn't work.
A quick Google of the GeoPandas Explorer says you can pick from the list supported by Folium. And so Folium has a very similar thing like what you did in contextually. You can list the tile providers and then get it from that. Or you can actually pass like custom URL if you have a set of tiles that you like, done on your own in like a PNG or TIFF format.
Right, and that's actually what this attribute method is, or argument is supposed to be. It's required. It's like a required argument. It's meant you can put like an href, like an HTML tag, and it'll show up down here to sort of to give credit. And I just put in a string because I didn't know where I just got the tiles for the tutorial, so I didn't bother putting in an HTML reference. But it does ask you to do that just to give credit or to acknowledge, or at least think about where you got your tiles from.
Okay. Cool.
Yeah. So I think, GeoPandas and these quick visualizations, I think going back to like QGIS or ArcGIS versus like when GeoPandas, like what use cases would be most helpful in. Sounds like heavy lifting, like sort of like some more those heavy lifting geospatial operations might be better suited for ArcGIS, but when it comes to like visualizing lots of data in a similar way, like creating a dashboard or the more data sciencey stuff like exploratory, exploring your data, that kind of thing. I think that's probably where GeoPandas comes in handy, like because in Python you could programmatically read a bunch of shapefiles or a bunch of GeoJSONs, take a look at each one, compare, and then if you got to do some more involved stuff, maybe ArcGIS would be better, or QGIS would be easier for that. But then you want to make a web dashboard or some pretty plots, that might be where GeoPandas comes in handy. And
I always argue that one place that code always trumps GUI interface is an automation, right? Like once you have to do something more than 10 or 12 times, you really start to want to put it in code, so you don't have to start clicking around every time, or you want to do it in the background. But having said that, QGIS and ArcGIS already have Python backends that you can automate with. So there's still a choice to be made.
I think there is a way, I think, to record what you've done interactively and have it become a macro, but I don't know about you folks, but when I'm stumbling around inside of ArcGIS, I'm not taking the quick path to my result. So I do not want to automate whatever it is I did.
Yeah. I mean, that was all. I wonder if anyone else has any more comments. Like, was this helpful for you? Are there other questions, or like, can this be made more relevant to your work, or has it been relevant so far? Just trying to gauge like how useful this particular topic has been.
I'd say for my research down the line, I was thinking of building a dashboard or a website for the DEP folks to kind of visually see real-time turbidity data and predictions across the Catskills. So I'd be eventually making interactive plots. So definitely down the line, I'll have to use it and get more familiar with these libraries because, like I said, I've mostly done this stuff in JavaScript and non-Python related stuff. So yeah, I really appreciate the intro. And when I have some free time, which is going to be scarce this semester, but in December or something, I'll start fiddling around with it. I really appreciate it, Noah.
Cool. That's good. Glad to hear. Thanks, Sharia. Oh, also, Turnbull sent around found it's through the libraries, right, Scott? Like the
Yeah, there was a
consulting.
notice to the GradNet. I sent a note to Noah and Pat that they have a service, basically a geospatial visualizations, consultant service through the library here at UVM. What's it say? It's a visit our website. Let me grab that, and I'll just drop it into the. You did
I
it?
just dropped it.
Okay,
Yeah.
you dropped it. They have a consulting service. So basically, what's ArcGIS, Google Earth Engine. They don't have GeoPandas here, but maybe we can invite them to the dark side. Yeah.
Well, great, Noah.
So-
Thanks. I'm going to stop recording here. I think that's a good spot to stop. And then